The sun himself is weak when he first rises and gathers strength and courage as the day gets on. Hi everyone. In this video, we'll go through partial fractions, different topics related to partial fractions. That is, how do we resolve partial fractions or proper fractions? How do we resolve partial fractions when there are repeated factors using coefficients and constants? And then resolving partial fractions for improper fractions. Now, if you observe this particular function, you have an equation in the numerator, an equation in the denominator, right? So this is a rational function. This is a rational function. Now, you can express this particular rational function in simple forms, in simple fractions, using simple fractions. And these simple fractions are called as partial fractions. Now, for example, I can take this particular rational function and can represent it as 3 by x plus 1 plus 2 by x minus 2. So this entire rational function can be expressed as sum of two simple fractions. This is one simple fraction, this is one simple fraction, right? So adding both of these simple fractions, I get this particular rational function. So these fractions are also called as partial fractions. This is called as partial fractions. Now basically, when we are asked to resolve, when we are given a rational function like this and we are asked to resolve using partial fractions, then we basically have to split. We have to split this entire rational function into multiple simple fractions or partial fractions. Degree of an equation, right? What is degree of an equation? Degree of an equation is the highest power of x or a variable. So now in this particular rational function, which is the variable? X is the variable, right? So what is the power of this particular x? There is nothing here, right? Which means the power is 1. So if you look at this entire equation, what is the highest power? It's 1. So degree is 1. We call degree of numerator is equal to 1. Now look at this denominator. You have two equations here. So when I multiply these two equations, what do I get? I get x into x is x square, x into 1 is x, minus 2 into x is minus 2x, minus 2 into 1 is minus 2. I further simplify it. I'll get x square, x minus 2x is minus x, and then I have minus 2. Now you look at the degree. The degree of x is, you have, what are the powers? What are the powers of this particular equation? You have 2, 1, right? This one is 2. There is nothing here, which means power is 1. Now, what is the greatest power here? It is 2. Therefore, we call degree of denominator equation is 2. So, numerator degree is 1. Denominator degree is 2, right? You don't have to multiply this every time to find the power. Here, you can take x and simply multiply only x and x. If I multiply x and x, I'll get x square, correct? So this becomes the degree, right? Now, if I had something like this, say like this, if I had an expression like this, now what is the degree for this? What is the degree for this? Here, simple. If I multiply this x with this x, I'll get x square, right? And then again, x square I multiply with this x. So I'll get x cube. So what is the degree? It's the highest power. What is the highest power? 3. Right? This way we find the degree of the equation. So degree of an equation is highest power of x. Now it could be any variable. It could be x or y or z, right? Any variable or any unknown in an equation. Now before we solve partial fraction problems, we'll have to understand what is a proper fraction and what is a improper fraction. Now what is a proper fraction? You first find the degree of numerator and degree of denominator. Now what is the degree of numerator? It is the highest power. So what is the degree here? It's 1, right? Because x has no power, which indicates it's 1. And here when I multiply x and x, I'll get x square. So the degree is 2. Now if you see, numerator degree is 1 and denominator degree is 2. So degree of numerator is less than degree of denominator. So therefore, this is called as a proper fraction. This function or this fraction is called as proper fraction because degree of numerator is less than degree of denominator. Now let's see what improper fraction is. In case of improper fractions, degree of numerator will be greater than or it can be equal to degree of denominator. Now take this example. What is the degree of numerator here? It is 2 because the highest power of x is 2. And what is the degree of denominator here? It is 2. Right? So degree of numerator is equal to degree of denominator. So this is improper. Now let's take another example. 5x cube minus 4 by x plus 1 into x minus 2. Now in this example, what is the degree of numerator here? The highest power is 3. So degree is 3. And here in denominator it is 2. So numerator degree is greater than denominator degree. Correct? So this is an improper fraction. This is an improper fraction. Now, how do we simplify this? What is the method? So what we do is, we take this denominator terms, right? You have, this is one term and this is second term, right? Second equation basically. What we will do is, we will take the denominator like this. One denominator, that is one fraction. Let's call this as first fraction, second fraction. In the first fraction, you will put the denominator as x plus 1. In the second fraction, you will put the denominator as x minus 2. And then you add in between, right? Now, we don't know the numerator, right? We don't know the numerator. So what we will do, we'll assume it is a and b, right? Finally, when we solve this entire rational function into partial fractions, it should be in this form, right? But we don't know the value of a and b. Now, instead of a, you could have 3. It could be 3 by x plus 1. Instead of b, we could have 2 by x minus 2. Now, these could be the partial fractions for this entire rational function. But we need to obtain this 3 and 2, right? So, we assume, right? As a first step, we assume that the numerator would be a and b. Actually, if I cross multiply this, I'll get 3 into x minus 2 plus 2 into x plus 1 by put both the denominators, right? I'm cross multiplying. I'm multiplying 3 with this expression and 2 with this expression. 2 into x plus 1 and 3 into x minus 2. And then I put both the denominators here. So what will happen? I'll get 3x, 3 into x and 3 into 2 minus 6 plus, now I'll multiply. 2 into x is 2x, 2 into 1 is 2, right? Divided by x plus 1 into x minus 2. This is x minus 2. So when I simplify, what do I get? 3x minus 6 plus 2x plus 2 by x plus 1 into x minus 2. Now I can add minus 6 with 2 and 3x with 2x. 3x plus 2x is 5x. Minus 6 plus 2 is minus 4 by the denominator. Now, you see, when I simplify these partial fractions, I'll get back the original rational function. Is it not? This function, this rational function, I'm getting when I use the simple fractions and multiply the simple fractions. So when I use the simple fractions and add the simple fractions, I will get the original rational function, right? So this is what we have to find out now. We'll have to find these simple fractions. We need to represent this entire rational function into simple partial fractions. Now let's take an example and resolve this into partial fraction. Resolve into partial fractions. So what is the first step? What we will do is, we'll put this, copy this as is, right? First, we need to check if it's proper or improper. Now, find the degree. What is the degree of numerator? It's 1. What is the degree of denominator? X into x square. So, degree of denominator is 2. So, here numerator degree is less than denominator degree, which means this is proper fraction. This is proper fraction. Now, what we will do, next step is, once we have checked that it's proper fraction, we need to split it. We need to split this entire function like this, right? A and B, and we put the denominator. So, first one we'll put as x minus 2, Second one we'll put as x plus 3. Now you have two methods to simplify this, right? First one is you can use LCM method, or second one is you can multiply the denominators. You can multiply the denominators on both sides like this. So you take this denominator. What is the denominator? X minus 2 and x plus 3. You multiply this x minus 2 and x plus 3 on both the sides like this. So we'll take x plus 1. You multiply with this denominator, x minus 2 into x plus 3. Then you copy everything as is. Now here what we will do, we'll take a and multiply both these denominators, x minus 2 into x plus 3 plus b into, again both the denominators, x minus 2 into x plus 3. Let's not forget to put the denominator x minus 2, and for b we have x plus 3 as the denominator. Now what we will do, we'll cancel the common terms, x minus 2, x minus 2, x plus 3, x plus 3. Here you have both the terms as common, you're cancelling it. So what do we get? We get x plus 1 here, and this is equal to a into x plus 3 plus b into x minus 2. This is equation, let's call as equation 2, and let's call this as equation 1, right? Let's call this as equation 1 and let's call this as equation 2. So first step is when you split it, you call this as equation 1. Second step is when you get an expression like this where you have removed the denominators. Basically, by doing this particular step, you will remove the denominators itself. Now what I will do is, as a next step, I will have to take the values of x, right? Now here I have x plus 3. So I will put x as opposite sign, minus 3. Here I have plus 3. I will say x is equal to minus 3. First one. Second one, here I have x minus 2. So it's minus 2. I will say equal to plus 2. Now I'll take these two values of x, right, and substitute in this equation 2. First I'll take this value of x, substitute it here. Then I'll take this value of x, substitute in this particular equation. Why I will substitute is, I will get the value of a and b. Our ultimate goal is to find the value of a and b. If we find the value of a and b, that means we have resolved this into partial fractions. So now, to find the value of a and b, we are substituting the value of x. Let's take case 1, right? Case 1 is put x is equal to minus 3. X is equal to minus 3 in equation 2. So what is equation 2? Let's copy it down. I'll put x is equal to minus 3. So instead of x, I'll put minus 3 plus 1 is equal to a into minus 3 plus 3. Instead of x, I'm putting minus 3. So I'll simplify. So minus 3 plus 3 will become 0. So I'll get 0 into a plus minus 5 minus 5b. So 0 is, you can ignore, it becomes 0. Plus and minus is minus. So minus 5b. And here it's minus 3 plus 1 is minus 2. I'll find the value of b. This is nothing but minus 5b is equal to minus 2. I'm just shifting it, right? So I'll get minus 5b as minus 2, which means minus and minus will get cancelled. I'll get 5b is equal to 2. Therefore, what is b? B is, I'm shifting this 5 this side. This is 5 into b. So when I shift, it will become division. So it will become division. So it will be 2 by 5, right? This 5 is at the top. When I shift, it will come to the bottom. That is in the denominator. So it will be 2 by 5. So b is nothing but 2 by 5. So I got value of b. Now what should I do next? I need to find the value of a. Now I'll take the value of x is equal to 2. The second case, right? The second case, I'll take value of x and put in this equation 2. Put x is equal to 2 in equation 2. Now let's copy the equation. Let's substitute value of x in this equation. So what I'll get? X is equal to 2. So it will be 2 plus 1. A into, instead of x I'm putting 2. So it will be 2 plus 3. Plus b into, instead of x I'm putting 2. So it will be 2 minus 2. So 2 minus 2 will be 0. 0 into b is 0. Right? I'll get 0 here. And this will be 5a. And this will be 3. Now I know 5a is equal to 3. Therefore, a is what? A will be 3 by 5. Basically 5A is equal to 3, which means A is equal to, I am shifting 5 this side, so it will become 3 divided by 5. So this is value of A. So now we got value of A also, we got value of B also. What is the next step? The last step, we take this equation 1 and substitute values of A and B, right? Now let's take this entire equation 1 and substitute values of A and B. So A is 3 by 5. So I'll put 3 by 5 and we have to put the denominator also. Denominator is x minus 2. Now what is the value of B? 2 by 5. So I'll put 2 by 5 and the denominator is x plus 3. So this is nothing but partial fraction. So now whatever answer I've got, right, I can verify if this answer is correct. How do I verify? I can cross multiply here and simplify this. I should get this function back. So let's try it out, right? This is just to verify if your answer is correct. So what we will do, we'll cross multiply. So I'll cross multiply this 3 with this entire term. So into 5 into x plus 3. I'm going to multiply. Then here again I'll cross multiply. 2 into 5 into x minus 2. And then I'm going to multiply both these denominators. 5 into x minus 2 and 5 into x plus 3. Now I'll simplify, right? So 3 into 5 is 15, right? 15 into x plus 3. I'll first multiply the numbers. 2 5s are 10. 10 into x minus 2 by, now let me multiply the numbers. So I'll get 25. Then I'll get x minus 2 into x plus 3. Now let's further simplify. So 15 into x is 15x. 15 into 3 is 45. Then 10 into x is 10x. 10 into minus 2 is minus 20. I'll just copy the denominator as is. Right? We don't have to multiply this. We'll leave it here. Now 15x plus 10x is, we'll add the similar terms. 15x plus 10x is 25x. 45 minus 20 is plus 25. Divide by 25 into x minus 2, x plus 3. I don't want to multiply the denominators, only the numerators will simplify. Now I can take 25 as common, right? If I take 25 as common, I'll be left with x. So since I've taken 25 as common, I'll be left with 1 here. I'll get 25 into x minus 2 into x plus 3. I can cancel 25 and 25. So what I'll be left with? X plus 1 by x minus 2 into x plus 3. Now observe, this is the original function. Both are same, right? So we have verified that the answer that we got is correct. Now let's look at problems related to proper fractions with quadratic equations. Now let's take another example. Now in this example, we have the denominator like this, right? It's a quadratic equation. What is it? It's a quadratic equation. What is quadratic equation? Equation which has power 2. That is, it's of the form ax square plus bx plus c. It's of this form, right? X square minus 6x plus 8. So you basically have x square, you have x, and you have constant or just the number. It's of the form ax square plus bx plus c. So you have x square, you have x, and then you have only number, right? This is a quadratic equation. Now, whenever we are resolving into partial fractions, we cannot have quadratic equation. We have to represent it in the form of linear equations, right? We cannot have quadratic equation or any expression with power as more than 1. Now you see power is 2. We cannot have power as 2. So we have to simplify this in the form of linear equation. What is a linear equation? It is of this form, ax plus b, right? This is a linear equation. So if you notice, x plus 1, x plus 2, all these are linear equations. Basically, x will have only power which is equal to 1, right? It will only have power which is equal to 1, right? There's nothing here, it means power is 1. X plus 1, x plus 2, x plus 5 plus 6. So these are all linear equations, right? So now we'll have to represent this entire equation in the form of linear equation. How do we do that, right? Let's solve this. We will have to factorize. Right? What is the sum? 3x plus 1 by x square minus 6x plus 8. Right? Now we will have to factorize this. Factors means you want to bring it into the form of linear equations. Right? Like x plus 1 into x plus 2. Like this we want to represent. Like the first example. Right? If you notice the first example, right? This is linear equations. We have to put the denominator in this form. So now there are three methods to factorize. Sum product, then you have formula, then you have direct method of getting the factors, direct method of getting factors. We'll go through formula method here. In the next set of problems, we'll go through sum product and direct method, right? Here in this problem, we'll use formula method. Now, what is the formula? You have to by heart this formula. Formula is minus b plus or minus root of b square minus 4ac by 2a. This is the formula. Now, what is this a, b and c? A, b and c are coefficients of x, right? Basically, a is coefficient of x square, b is coefficient of x, c is constant or number only, number without x. Now, if I take this particular equation, x square minus 6x plus 8, what is the coefficient? Number next to x. Number next to x. Now, you have x square. You don't have any number here. When you don't have any number, you assume there is 1. So, 1 is the coefficient. So, here a becomes 1. A becomes 1. And b is coefficient of x. What is the number next to x? It is 6. We'll have to put the sign also. It is minus 6. Minus 6. So, we'll have to put as minus 6. Constant. Constant means this one. It's just a number, right? There is no x in this, right? So, this is constant. This is nothing but plus 8. Now, we will substitute this a, b, c values in this formula and get the values of x. We'll basically get the values of x. I'll put x is equal to minus b. What is b here? Minus 6. We already have minus here. And then b is minus 6. So, minus of minus 6 plus or minus. You have to put this plus or minus root of b square. What is b? Minus 6 whole square minus 4 into what is a? 1. What is c? 8. Divide by 2a. 2 into a. A is 1. Now, we'll simplify this. So, minus into minus is plus. So, 6 plus or minus 6 square is 36 minus 32 by 2. Now, this will be 6 plus or minus 36 minus 32 is 4 by 2. Now, we'll have to split this. That is, you have to write this as 6 plus root 4 by 2 and 6 minus root 4 by 2. That is, you take this entire expression with plus and then with minus, with plus and then with minus. So, now we'll get two values of x. Put a comma here. This is one value of x and this is another value of x. So, this will become root of 4 is 2, right? Root of 4 is 2. So, it will be 6 plus 2 by 2. This will be 6 minus 2 by 2. So, I'll get 6 plus 2 by 2 is 8 by 2. 8 by 2 is 4. 6 minus 2 is 4. 4 by 2 is 2. So, these are the two values of x. What are the values of x? 4 and 2. Now, I should write it in the form of linear equation. How should the linear equation be? It should be like this. X plus 1, x minus 2, x plus 4. In this form, it should be ax plus b is equal to 0. This is how we represent linear equation. Ax plus b. Now, we have two values of x, right? 4 and 2. So, what we'll do? The values of x is equal to 4 and another value of x is equal to 2. Now, we'll have to write this as x minus 4. I shift 4 this side. What will happen? This is plus 4. When I shift, it will become minus 4. Here again, when I shift 2 here, what will happen? It will become x minus 2. So, these are the two linear equations. So, this entire denominator that we had, we'll have to write it as 3x plus 1 by x minus 4 into x minus 2. So, now you see, we have converted this quadratic equation into linear equation. right? Now we'll go with the step where we have to split this. How we will split? We have two terms here, right? In the denominator. First, observe how many terms we have in the denominator. Basically, how many equations. This is one equation, this is second equation. So I'll have two variables, a and b, right? And then I add it, a and b. Then now I put the denominator. First one is x minus 4. Second one is x minus 2, right? We can put it like this. Now you can put this as b or you can put this as a. The order doesn't matter, but you just have to find the values of a and b and put these denominators. Then only it becomes a partial fraction. So now we can solve this problem. There are two methods here, right? To simplify, you can cross multiply the denominators. Cross multiply the denominators, or you can take LCM method, right? Let me go with cross multiplication. LCM method is simpler actually, but let's go with cross multiplication. We'll go with LCM method in the next set of problems, right? Now here I'll cross multiply. So what are the denominators? These two are the denominators. So I'll multiply a with both the denominators, x minus 4 into x minus 2, plus b with, again same thing, x minus 4 into x minus 2. And what will happen to the denominator here? I'll have, here I have x minus 4. For b I have x minus 2. Now on the left hand side also have to do the same thing. So I have 3x plus 1 by x minus 4 by x minus 2. Don't put this, right? These linear equations. Now I have to cross multiply here also, right? With these denominators, x minus 4 and x minus 2. So I have taken both these denominators and multiplied here. Now what will happen? This and this will get cancelled. This and this will get cancelled. Here x minus 4 and x minus 4. Here x minus 2 and x minus 2. So basically I have removed the entire denominator. Now there are no denominators at all. So I will rewrite this. I'll write it as 3x plus 1 is equal to a into x minus 2 plus b into x minus 4. Now we call this as equation. Let's not forget, we call this as equation 2. And this is equation 1. Let's not forget, this is equation 1. This is equation 1. Finally, once we find the value of a and b, we have to substitute the value of a and b in this equation. Now, what is the next step? We have to substitute, right? What do we have to substitute? X. Now, how do we know the values of x? Simple. Here you have x minus 2. So we'll put opposite sign. It's minus 2, we'll put plus 2. This is one value. Second value of x here. Here you have minus 4. We'll take the opposite sign, plus 4. So first time we'll substitute with 2. Second time we'll substitute with 4. We'll get the value of a, we'll get the value of b, and then put those values in equation 1. Let's solve it, right? So put x is equal to 2. Again, order doesn't matter. You can put x as 4 first or x as 2 first. Order doesn't matter. So I'll put x is equal to 2. So I'll get 3 into 2 plus 1 is equal to a into 2 minus 2 plus b into, instead of x I'm putting 2. So it will be 2 minus 4. I'll get 0 into a, which is 0, plus 2 minus 4 is minus. 2 minus 4 is minus. So I'll remove this plus. I'll put minus 2b. Here it is 6 plus 1, which is 7. Now I'll find the value of b. What will be b here? B will be 7 by 2 and minus. 7 by minus 2, right? B will be 7 by minus 2, which is nothing but minus 7 by 2. This is the value of b. Now we'll find value of a, right? So for that we'll put x is equal to 4. So let's take that equation, copy paste this equation, and instead of x I'll put 4 plus 1 is equal to a into, instead of x I'll put 4 minus 2 plus b into 4 minus 4. So this will become 0. This will become 4 minus 2 is 2, 2 into a. This will be 3 4s are 12, 12 plus 1 is 13. Therefore what is a? A is equal to 13. I'll bring down 2 because this is multiplication. When I shift it to the other side, it will become division. So it will become 13 by 2. So a is 13 by 2. So we got the value of a also. Now we go to the final step. We take this equation, right? We take this equation. What do we have for a? 13 by 2. 13 by 2 into x minus 4 And what do we have for b? Minus 7 by 2. It's minus, so we'll put minus 7 by 2. Let's copy the denominator, which is x minus 2. This is the set of partial fractions now. So these are the partial fractions for this particular rational function. Now let's take another problem, slightly more complex. Here we have both linear equation and quadratic equation in the denominator. So let's solve this. But let's remember, every time before starting the problem, you'll have to figure out if it is a proper fraction or improper fraction. So we'll have to look at the degree of the numerator and degree of the denominator equations and then determine if it is proper or improper. Degree is nothing but power of x, right? Here the power of x is 2. Here the power of x is 1, right? Here there is no x. So, but the highest power of numerator, what is the highest power of numerator? 2. So this 2 is the degree of numerator. So I would call this as numerator and this is denominator. Now what is the power here? When you multiply this denominator with this particular term and this particular term, you are going to get x cube, is it not? X square into x is x cube. Then what is the power? Power is 3. Now you see that the degree of numerator is less than degree of denominator. Hence this is a proper fraction. Now we'll have to split this into partial fractions. We have this quadratic equation here, right? First we need to factorize these equations. It has to come in this form, like x plus 1 or x plus 2. There are multiple ways to factorize: sum product method, formula method, direct method, right? Now if it is simple problems, we can factorize it directly. If it is slightly complex, then we might have to use formula method. And for some problems, we can use sum product method based on the complexity of it. Now here we have this particular quadratic equation. We can use formula method. This is the formula: minus b plus or minus b square minus 4ac by 2a, right? A, b, c are the coefficients. What are coefficients? Coefficients are nothing but numbers which are next to x. So for example, in this case, the number next to x square is 1. So a is equal to 1. Number next to x is minus 5. So b is equal to minus 5. And then we have constant, which is simply the number without x. And here c is equal to 6. So in this case, a is equal to 1, b is equal to minus 5, c is equal to 6. So we'll have to take the signs also. Take these coefficients, substitute in this formula, and then you'll get two values of x. One is when you add, when you use plus, and the other one is when you use subtraction, right? So you'll get two values, 3 and 2. The way we have to write these factors is, here we have got directly x values. So we've got x is equal to 3 and x is equal to 2. So we'll have to write this as x minus 3, x minus 2. Why? Because when x is equal to 3, if I shift 3 to this side, I'll get x minus 3 is equal to 0. And when I shift 2 this side, I'll get x minus 2 is equal to 0. So the factors are x minus 3 and x minus 2. The other method is sum product, right? Here you'll have to choose two numbers in sum product. So minus 5x plus 6, x square minus 5x plus 6. Choose two numbers such a way that this is the sum and this becomes the product, right? So now sum has to be minus 5. So you have to choose two numbers, number 1, number 2. And when you add these two numbers, you should get minus 5. And when you multiply these numbers, you have to get 6. So we can take 3 and 2, because when we multiply in 3 and 2, we'll get 6. And when we add 3 and 2, we'll get 5. But we'll have to get minus 5. That means both of these numbers should have minus, because when you add minus 3 and minus 2, you're going to get minus 5. And when you multiply minus 3 and minus 2, you're going to get plus 6. So here we get minus 3 and minus 2. The way we'll have to write this is x minus 3 and x minus 2. This is how we'll have to write. Direct method. How would I do it in the direct method? This is like this, right? I'll have to split This is direct method. Split minus 5x into two terms. So I can write it as 5x can be written as 3x and 2x. I can write it as 3x and 2x. Since there is minus 5x, I'll have to write it like this, right? I can write this as minus 3x and minus 2x. So when I add these two, it's going to be minus 5x, right? This is another way. Now here I'll take common factor. Here between these two I can take x as common. So I'll get x minus 3. And between these two I can take 2 as common. I'll take minus 2 as common. So I'll get x. Since minus has been taken out, this will become minus. Less will become minus. And 2 3s are. So I'll get this. Now if you notice, again here x minus 3 is common. So I'll get x minus 2. So the factors are x minus 3 and x minus 2. So there are multiple methods. 3 methods I have already mentioned. So you may need to practice all of these methods to arrive at the factors. And this is very important for resolving partial fractions related problems. So from all 3 methods, we know that the factor is x minus 3 and x minus 2. So now we'll write this as x square minus 10x plus 13 by x plus 1. We can write this as x minus 3 and x minus 2. This is equal to, we'll write a by, we'll take this one, x plus 1 plus b by this one, x minus 3 plus c by x minus 2. This one. So we've splitted these 3 denominator terms to 3 separate terms. We can take LCM, or you can multiply on both the sides by the denominator, right? Again, there are 2 methods. You can either use LCM or multiply on both the sides by denominator. If I multiply both the sides by the denominator, that is like this, x square minus 10x plus 30 into x plus 1, x minus 3, x minus 2. So I'll multiply both the sides with the denominator terms. So I'll get this, then divided by x plus 1, then plus b by x minus 3 into all the denominator terms, plus c into all denominator terms by x minus 2. Now if you notice, you can cancel x plus 1, x plus 1, x minus 3, x minus 3, x minus 2, x minus 2, and here we have this denominator already on the left hand side. So here all these terms will get cancelled. So we'll be left with x square minus 10x plus 13 is equal to a into x minus 3 into x minus 2 plus b into x plus 1 into x minus 2 plus c into x plus 1 into x minus 3. So basically, other than this term, these 2 terms will get associated with a. For b, other than this term, these 2 terms will get associated with b, right? Now in this equation, we'll take values of x. We'll take x is equal to 3. We have x minus 3, so we'll take the opposite sign, x is equal to 3. Here we have x minus 2, so we'll take x is equal to 2. Here we have plus 1, so x is equal to minus 1. Now using these 3 values of x, we'll substitute all these values of x in this equation one by one and get values of a, b and c, right? Now let's substitute first one with x is equal to 3. You will get 3 square minus 10 into 3 plus 13 is equal to a into 0, because 3 minus 3 is 0, and 3 minus 2, plus b into 3 plus 1, 3 minus 2, plus c into 3 plus 1, 3 minus 3, right? Now there is, since 0 here, this will become 0, plus b, 4b and 1. We'll get 4b plus 4, this is 0, this will become 0, right? And here we're going to get 9 minus 30, 9 minus 30 plus 13, you will get minus 8 is equal to 4b, which means b is equal to minus 8 by 4. So we get b is equal to minus 2. Now we'll find the second one. Now we'll take the second term, which is x minus 2. Now we'll assume x is equal to 2. So let x is equal to 2. Now take 2 and substitute in this entire equation, 1. So we'll get 2 square minus 10 into 2 plus 13 is equal to a into 2 minus 3, 2 minus 2, which is 0, plus b into 2 plus 1 into 2 minus 2 plus c into 2 plus 1 into 2 minus 3. So on solving this, we'll get 4 minus 20 plus 13, we'll get 0. This will be 3, this will be 0, minus 3c. This will be 3 and this will be minus 1. So minus 3c. And this is minus 3. Minus 3 is minus 3c. This is nothing but c is equal to minus 3 by minus 3. C is equal to 1. So now we have got the values of b and c. Now we will have to find the value of a, right? We have taken x is equal to, we have finished x is equal to 3 and x is equal to 2. Now we will have to take x is equal to minus 1, right? So let's take x is equal to minus 1 and substitute in this equation. So on substituting x is equal to minus 1, we will get this particular expression. So on simplification, we will get 12a is equal to 24. Thereby, we will get a is equal to 2. Now that we have got all the values of a, b and c, we will take the original expression where we had split it in terms of a, b and c and substitute the values of a, b and c. So on substituting, we will get a is equal to 2, 2 by x plus 1, b is equal to minus 2, minus 2 by x minus 3, c is equal to 1 plus 1 by x minus 2. So here we have got the partial fraction. Now let's take another example. We'll have to first check if this is a proper fraction or improper fraction. Now look at the degree of the numerator. Degree of numerator is 1, right? There's nothing for x, no power, which means it's 1, right? So this is the degree, 1. What is the degree of denominator? You have x square. When you multiply x square with x, right? When you actually multiply, you will get x cube. So what is the degree? It's 3. So degree of numerator is less than degree of denominator. Therefore, this is proper fraction because degree of numerator is less than degree of denominator. Here, what we'll have to do is, we'll have to first, see, basically we'll have to remove all these squares. Squares, cubes cannot be there. We'll have to get the x value to a single degree, right? We cannot have 2 as the power or 3 as the power or anything. The power should be only 1. So we have to simplify this denominator to have x values with power as 1 only. We can write this as x plus 3 by x minus 1, x square minus 4. You can write x square minus 4 as x square minus 2 square, right? And you can write this further as x plus 2 into x minus 2. You should always remember this formula. A square minus b square is a plus b into a minus b, always. So here if you have x square minus 2 square, you have to write this as x plus 2 into x minus 2. This is a very important formula used in entire mathematics. So we can split this as x plus 2 into x minus 2, right? So now we'll write this as a by x minus 1 plus b by x plus 2 plus c by x minus 2, right? And we'll copy the left hand side as is. Now when you multiply both the sides, you can either use LCM or multiply on both the sides. I'll use the LCM method here. I find LCM method more simpler because it's going to avoid multiple steps. LCM for this will be this one. This is the LCM. Now there is already x minus 1 here. So you'll have to cross multiply with this. That is, we'll have to cross multiply with x plus 2 and x minus 2. So I will get a into x plus 2 into ax minus 2. Here again x plus 2 is already here. So I have to take the other two terms and multiply. B into x minus 1 into x minus 2. Now plus c into x minus 2 is already there. So I'll have to multiply with the other two terms. That is x minus 1 and x plus 2. Now I'll copy the left hand side. Now if you notice, the denominators are actually same, right? So I can cancel. This. Now I have this simplified expression. You will have to take x is equal to all of these values, right? We'll have to take x is equal to plus 2 means minus 2. Minus 2 means plus 2. Then minus 1 means plus 1, right? Just reverse the signs and take those values as x. So we'll take x is equal to minus 2 first time, right? For the first case. So let me substitute x as minus 2 in this entire expression. So I'll get minus 2 plus 3 is equal to a into minus 2 plus 2 is going to become 0 plus b into minus 2 minus 1 minus 2 minus 2 plus c, this is going to become 0 because minus 2 plus 2 is going to become 0, right? So I'll get 0 plus minus 3 minus 4, that is plus 12. So I'll get 12b plus 0 and this is 1. 12b is 1. So we get b is equal to 1 by 12. So we assumed x is equal to minus 2. Now we'll take x is equal to 2. Let x is equal to 2. So when you substitute x as 2, you will get this particular expression. 5 is equal to, this will become 0. This will become 0. So 0 plus 0 plus 2 minus 1, 1, 1, 4. 1 into 4, 4c. So c is equal to 5 by 4. Now we'll assume let x is equal to 1. 1, that is this one. Here x minus 1. So we'll take x is equal to 1. When x is equal to 1, so we'll get this particular expression when we substitute x is equal to 1. So we'll get 3 minus 1. So we'll get minus 3 plus 0 is equal to 4. So a is equal to minus 4 by 3. Now we'll substitute the values of a, b and c in this particular expression where we are splitted into a, b and c. So now in this expression we'll substitute all the values. So we got a as minus 4 by 3, b as 1 by 12 and c as 5 by 4. So this is the partial fractions. Let's discuss on the next topic, which is related to repeated factors using coefficient method and constant method. Here's a problem which is related to repeated factors. So when you have something like this, x plus 3 the whole square, this is nothing but a repeated factor because x plus 3 the whole square is nothing but x plus 3 into x plus 3. So this is repeated. Since this is repeated, we call this problem as having repeated factors. So here how we should split is, we will first take a, take x minus 2, then we'll take b, we'll take x plus 3, and then we'll take c, same thing, x plus 3 the whole square. So once with x plus 3 and second time with x plus 3 the whole square. So this is how we'll have to split. So b with x plus 3 and c with x plus 3 the whole square. You can interchange this, right? You can have c here and you can have b here. That doesn't matter. Denominator what matters? One denominator should be x plus 3. The other denominator should be x plus 3 the whole square. So now I'll take the LCM, right? LCM for this would be x minus 2 into x plus 3 the whole square. If you're not comfortable with LCM method, then you can multiply on both the sides with all these factors, right? On both the sides you can multiply. You can multiply with x minus 2 and x plus 3 the whole square. You can multiply on both the sides. So I find this easier because it reduces one step for me. If you want to understand the LCM method, then do drop in your comments. I can prepare a separate video on LCM method. So now when I use LCM, I'll get x minus 2 and x plus 3 the whole square. So now I'll have to multiply. X minus 2 is already here. So I'll have to take this one. A into x plus 3 the whole square plus b into x plus 3 is here. 1 x plus 3 is here. So another x plus 3 we need to put here. And x minus 2 plus c into x plus 3 the whole square is here. So x minus 2 has to be put. So we'll get, so now denominators will get cancelled and we are left with this particular expression. Now we'll have to take the values. We'll have to take, we can take x is equal to, here it's plus 3, so we'll take x is equal to minus 3. Then x is equal to plus 2. Because it's minus 2, we'll take it plus 2. Here it's the same thing, so let's leave it. So let's take x is equal to minus 3 and substitute. So on substituting x is equal to minus 3 here, we get this becomes 0, this also becomes 0, and this will become minus 5c. So we get minus 7 here. On simplification we get c is equal to 7 by 5. Now let's put x is equal to 2, this one, right? When we put x is equal to 2, we'll get 3 into 2 plus 2 is equal to a into 2 plus 3 the whole square plus b into, so we'll get 25a plus 0 plus 0 is 8, which means a is equal to 8 by 25. So now on substituting x is equal to 2, we'll get a is equal to 8 by 25. Now we got the value of c and we got the value of a. Now we need to find the value of b, right? Now how do we find the value of b? We have already utilized this value, x is equal to minus 3 and x is equal to 2. Now to find the value of b, we need to have another x value. Here we had only two values for x. X is equal to 2 and x is equal to minus 3. So with these x values, we found values for a and c, but we still have to find the value of b. To find the value of b, there are two methods. Either we have to use coefficient method or constant method. Simple, what we have to do is take the coefficients of x square from this expression, right? Here, from this expression, we take the coefficients of x square, and here also we take the coefficients of x square, and from the equation we find out the value of b. We can also use another method called as constant method, right? First let's figure out coefficient method. Let me copy this expression there. So we'll take the coefficient of x square here. So when you multiply x plus 3, this is nothing but x plus 3 into x plus 3, correct? This expression is nothing but x plus 3 into x plus 3. When you multiply x into x, you are going to get x square. What is the coefficient of x square? That is a number next to x. There is no number, means there is 1, right? So coefficient of x square is 1 here. So we'll put 1a. Then here, what is the coefficient? Again, it's x square. There is no number, so we assume it's 1b. And here, there is no x square itself. If there is no x square, then it is 0. So it is 0c, right? Now, here also there is no coefficient of x square. There is no x square here. Since there is no x square here, we don't have the coefficient. So we'll assume it is 0, right? We are just taking coefficients from this equation. Now, we know the value of a, which is 8 by 25. B, we'll have to find out. And this is equal to 0. Now, this means b is equal to minus 8 by 25. So, here we have obtained the value of b. Now, there is another method, constant method. So, in this equation, we'll take the constants. Constants is we have to take the numbers, only numbers without any x in it. Now what is x plus 3 the whole square? It is nothing but x plus 3 into x plus 3. Now you take the numbers in this. Numbers are 3 and 3. When you multiply 3 and 3, you're going to get number 9. So 9 is the constant here. It will be 9a. Now again here, when you multiply, just numbers you have to multiply. 3 into 2 is 6 and there is minus here. So minus 6b. And here constant. Constant is minus 2, only minus 2. So minus 2c. Minus 2c. And what is the constant here? Constant is plus 2. Only number. So 2. We'll substitute the value of a. A is 8 by 25. Minus 6b. B we have to figure out. Minus 2 into c. C is 7 by 5. So now we'll calculate. Now on simplifying all of this, there are multiple calculations. Basically, you'll have to take the LCM, subtract, multiply and all of that. And finally, we get the value of b, which is minus 8 by 25. Now, we got the same value for b, right? Whether we use the coefficient method or we use the constant method, we got the same value. Only reason I prefer coefficient method is here the calculations are simpler, right? But in this case, the calculations are slightly lengthy. Now, finally, you take the original expression with a, b and c, substitute the values of a, b and c, and then you get this particular partial fraction. Now, let's look at problems related to improper rational functions. Here's an example which is related to improper fractions. Here, if the degree of numerator is greater than or equal to degree of denominator. What is a degree? Degree is nothing but highest degree of the polynomial function. Now, this is a function. What is the highest degree of x? Degree is the power, right? What is the highest degree? It is 2. Power of x is 1 and power of x square is 2. But highest degree for this entire function is 2. For numerator it is 2 and for denominator also it is 2. So here degrees are equal. If the degrees are equal, then it's an improper fraction. Assume if the degree was 3, if it was x cube here instead of x square, then the degree would have been 3. Even in that case, degree of numerator would be greater than degree of denominator. So either ways, if the degree of numerator is greater than or equal to, then we call it as an improper fraction. Every time a partial fraction problem is given, first check is to see the degree of numerator and denominator. Check if it is proper fraction or improper fraction. If it is an improper fraction, then we'll have to do an extra step of division. We'll have to divide. So we'll take this denominator here, take the numerator here and then divide. So how do we divide? Now here you have 2x square minus 7x plus 1. So and here we have x square. So we'll have to multiply some number with x square, some number with x square so that we get 2x square. This first one. So we have to multiply 2. So x square into 2 becomes 2x square. Why should we do that? Because so that we can cancel the terms. So now 2x square and 2x square will get cancelled. And then we'll have to multiply these remaining terms with 2. So 2 into minus 3x is minus 6. 2 into 4 is minus 8. And then we subtract the entire thing and we get minus x plus 9. Now there are no other terms here, right? Assume that there was something else here, say 8x cube, for example. Then we'll have to bring this down. We'll have to bring this down and then continue the same process, right? Now this is not there, right? So we end it up here. So this is the remainder. This is the remainder. This is the quotient and this is the divisor or the denominator. Now, so we will be writing this entire improper fraction like this. We'll write the quotient here, quotient plus this one remainder by denominator or divisor. So this one, remember this quotient always, right? In the final step, when we have splitted the partial fractions, we have to remember to add this quotient. Now we'll take this particular fraction and resolve into partial fractions. Now we get this particular proper fraction. right? Now we'll use the same method, split it up into a by x minus 4 and b by x plus 1. Now here denominator we'll have to factorize, right? We'll have to factorize this. So like I said, there are three methods: direct method or method of splitting, sum product method, and formula method. So whichever method is comfortable, right? So I've used all the methods here, right? If you use sum product method, sum should be minus 3, this one, product should be minus 4, and you should choose two numbers whose sum, that is when you add these two numbers you get minus 3, and when you multiply two numbers you get minus 4. So now you'll have to guess what those numbers are. So immediate guess is minus 4 and 1, because minus 4 into 1 is minus 4, minus 4 plus 1 is minus 3. So you'll get minus 4 and 1 as the numbers. So we'll have to write it as x minus 4, and this plus 1. So x plus 1. So these are the factors. So now you'll have to write these factors here. Okay. Then the normal process, you split it up into a and b, and then you take the x values. Here x will be minus 1 and here x will be plus 4. Now substitute x is equal to minus 1 and you'll get the value of b. Then you substitute x is equal to 4 and then you'll get the value of a. Now you substitute a and b values and you get the final answer. But remember to put the quotient, right? Most of the times we forget to put the quotient. Since this was an improper fraction, we'll have to put the quotient here. Quotient we had got was 2. This was the quotient we had got. So finally we have to add 2 to this entire partial fraction. Now let's take another example. Here there is x cube and denominator has x square. What is the degree here? Degree is the highest power. So the highest power here is 3, right? In this entire numerator expression, the highest power is 3. Degree for numerator is 3 and degree for denominator is 2. So numerator degree is greater than denominator degree. Therefore this is an improper fraction, right? Now since it's an improper fraction, we will divide. So we'll take this denominator here, put the numerator here, and now let's solve this step by step so that it becomes clear. So now what I will do, I'll take this x square first, right? And here the first term is x cube. Now I have to multiply this x square with something so that I get x cube. Now if I multiply x square with x, I'll get x cube, correct? So I'll have to put x here and then multiply. X square into x is x cube. Now I'll take these remaining terms and multiply with this. So 5x into x is 5x square. 6 into x is 6x. Right? Let me subtract everything. So when I subtract, x cube and x cube will get cancelled. So when I subtract this, I'll get 2x square plus 11x, and then I'll carry forward this one. I'll carry forward this one plus 11. Now I'll have to continue this one more time because I carry forwarded this number. I have to do this entire cycle once again. Now I'll have to do the first term, which is 2x square. What should I multiply with x square so that I get 2x square? It should be 2. So let me first put plus. I should multiply with 2 plus 2. X square into plus 2 is 2x square. Now let me multiply this entire thing with 2. So I'll get 2x square. 5x into 2 is 10x. 6 into 2 is 12. Now let's subtract. This will get cancelled and I'll get 11x minus 10x is x. 11 minus 12 is minus 1. Now there is nothing to carry forward. Thereby I end it here. So this is the remainder, right? This is the remainder. This is the quotient and this is the denominator or divisor. Remember this quotient because we are going to add this finally to the partial fraction. This is how the polynomial function will be, right? X plus 2 plus this expression. We'll have to put the quotient here plus the remainder and then the divisor. So this is the final polynomial function. Now we'll take this proper fraction and we'll use the normal process of finding values of A and B. We'll split this, find the value of A and B, right? And then we get the value of B, we get the value of A, we substitute in this equation, right? And then finally put the quotient. With this, we've come to the end of this particular topic. If you like this video, do press a like and share it. Thank you.